What's up, guys? Here we are back at it again, solving equations. I'm excited. I hope you're excited. Here we go. We are going in 2.4 to be doing the exact same thing we've been doing. Solving equations, isolating the variable of interest. That's a lie, we will end this, but theoretically we're never going to stop doing this. So similar to what we've been doing, we're going to continue solving. So let's jump right into it. First problem of the day, 6x plus 3 equals 8x minus 21. Again, what's the whole goal here? What's the big picture? We want to get x by itself. Now, the slight change you may notice in this type of problem is x is on both sides, okay? We've got variables on both sides of the equations, but that's okay because what did we learn in 2.3? We learned how to combine like terms. So we're going to start the whole process by combining the like terms here. I need to combine the 6x and the 8x on one side, and on the other side, I want to get the 3 and the negative 21 together. That are my constants on one side, the variables on the other, and I should basically have a one-step equation. Now, it doesn't matter where you start. You could start this a million ways. You could subtract 6x from both sides to start. You could subtract 8x from both sides to start. You could add 21 to both sides to start. You could subtract 3. It doesn't matter. If you don't believe me, try it. Start this problem all 4 of the different ways I just said. Move whatever you want to start and you'll still get the same answer. Don't believe me, try it. I personally am going to start with moving the 6x, okay? Why am I going to move the 6x? Well, if I subtract 8x from both sides, I'm going to end up with negatives. And I can, but I prefer not to work with negatives. So I'm going to subtract the 6x. Subtract 6x from both sides, and I'm left with 3 equals 2x minus 21. Okay, great start. Again, I want to get all the constants on the other side, so my next step is pretty clear. Add 21. I get 24 equals 2x. Divide both sides by 2. And we're going to get an answer of x equals 12. Again, how can I check that? Plug it back into the original equation. If you do that, 6 times 12, I believe gives you 72. 72 plus 3 is 75. Over here, we do 8 times 12. So if 6 times 12 is 72, 84, 96, I believe is 8 times 12 is 96, minus 21, again, 75. Check my mental math in a calculator. But again, folks, nothing is changing here. It's all the same stuff. Okay? So that's how we solve equations with variables on both sides. So I'm confident in you all. Let's go ahead and jump to a word problem, okay? What's this look like in words? I know you all love word problems. We're talking about skating here. Is buying skates or renting skates the better option? It costs $40 to buy skates. Either way, you have to get safety equipment. Safety equipment costs $1.50 an hour if you own your own skates and $3.50 if you rent skates. How many hours of skating would it take to make buying skates worth it? We've talked about this. Some of you have talked about this in person. Some of you haven't quite learned this yet. I promise we'll talk about it if you haven't learned in person yet. But word problems are really simple. We just have an extra step. We got to take all the information they give us and create the equation ourselves. Then we'll solve it. Okay? So a lot of info here, but let's highlight what's important. It costs $40 to buy skates. That sticks out to me, specifically the 40, as an important piece of information. Okay, other important numbers. Safety equipment costs $150 if you own your own skates, and it costs $3.50 an hour if you rent skates. How many hours of skating would it take to make buying skates worth it? What we're getting at here is actually common in most business models, right? If we go a couple times, you do some mental math here, renting skates is going to be a lot cheaper than buying skates because we got that initial $40 cost. But if we're going to go all the time, maybe buying makes more sense because once we get past the initial cost, it's only $1.50 an hour. That might save us some cash. So let's logic through it together. So 3 key pieces of information. I've got a $40 initial fee if I want to buy skates, right? But that's a one-time fee. Okay? Notice, I'm going to come back to that. One-time fee. It's $1.50 an hour to rent the safety equipment if we own. And again, $3.50 an hour to rent if we do not own. So if we're just renting. Okay. So let's think about this. Okay. The question is, how many hours of skating would it take to make buying skates worth it? I hope what you're seeing is we have 2 contrasting ideas here. We've got the renting and the buying. And we want to know how many hours of skates would it take to make, or how many hours would it take to make it worth it? That implies that there's some break-even point, right? Clearly at the beginning, right, if we're only skating a little bit, renting makes sense. But as we skate more and more, renting and buying get closer together, and there's a breaking point. We're going to find that. So how do we set this up? Well, since they're contrasting each other and there's a break-even point, I'm going to have renting on this side, and I'm going to have if I own skates on the left side. Okay? So what's this look like? Let's actually throw it together. So if I'm buying skates, what are my costs? Well, I've got a $40 initial fee, but again, that's a one-time fee. You buy the skate, you got the skate. You don't have to rent skates. So there is no variable associated because it's a one-time fee. But the $150, again, it's $1.50 if you own your own skates for the safety equipment. I have to pay every single time I go. Now, do we know how many times we go? No, we don't. I'm going to call that X. X is the number of hours I skate. We don't know that, right? How many hours of skating? We don't know that yet. So we're going to give it a variable. So the combination for buying is made up of that initial fee and then $150 per hour. The renting has no initial fee, so there's no constant on the right side, but it's $3.50 an hour for the safety equipment. And again, we don't know how many hours we go. Now, the key is both sides are comparing how many hours, right? X is the number of hours skated, so I use the same variable on the right side as I did the left. Now, if we look at what's boxed here in red, it's just an equation like the one we solved above. So what am I going to do here? How many hours would it take for me to break even where buying starts to make sense? Well, I've got the equation set up. Now I'm going to solve it. So I subtract 150 from both sides. Again, this is a great point. If you're confused about how I set this up, pause this video and shoot me an email. Or talk to me in class, make a little star in your notes. So I'm going to subtract 150 from each side so to get all the x's on the right side. When I do that, I get 2x equals 40. Again, there's a decimal here. Keep that in mind. How am I going to get x by itself? Well, I divide by 2, and I get 20 equals x. What does that mean? That means I have to skate for 20 hours before buying makes sense. Now, look, please listen to what I just did there. I explained my answer in the context of the problem. You might be new to that. This is a skill I want you to develop. Not only do I just go, oh, 20 equals x, but in a word problem, explain it in the context. How do you explain it in the context? You go back to what your variable represents. 20 equals x. Well, if x is the number of hours I skate, then 20 hours of skating will make me break even. Again, if you're confused or struggling here, pause the video, shoot me an email. But other than that, we will move on. Okay, so let's go back up here. We got a little bit of space. We're going to solve a couple more problems in this video. So let's solve 9 plus 5n equals 5n minus 1. Now you might be sitting there going, Mr. Carter, I am a pro at solving these, right? I did the word problem, A-okay, little trip up, but I'm A-okay. And I solved the one before. I got this, okay? My guess is you started somewhere. Again, it doesn't matter where you solve. I'll start with subtracting 5n from both sides. All right, well, I'm going along here. Subtract 5n, that cancels, and whoa. 5n minus 5n, that cancels as well. So I'm left with 9 equals negative 1. That doesn't seem right. 9 equals negative 1. Oh, that's not possible. So I must have messed up. So I go back. Here's the hint. I didn't mess up. So let's say I start with, okay, I messed up. Add 1, and I get 10 plus 5n equals 5n. Get the constant alone, get the variable alone. Subtract 5n, and oh no, I'm going to end up with 10 equals 0, because the 5n's will cancel on both sides, so I have nothing. Well, that doesn't make sense either. See, here's the catch. When you run into situations where variables are on both sides, there's always the chance of running into this problem. And if you ever hit a problem, assuming your math is correct, you get 10 equals 0, or what was it, 9 equals negative 1, we know this is a false math statement. This is incorrect, false, not true. What does that mean? Your answer to these types of problems will be no solution. Typically, when we've solved equations to this point, there's been one answer, right? One number I could plug in for n, and it makes both sides of the equation equal. But sometimes for certain equations, there's no solution. That means there's no number out there that I could plug in for n and make both sides equal. If you don't believe me, try it. Okay, so watch out for this. If you get a number equals another number and you know it's not true, no solution. Let me throw one more type of problem at you. Let's say I have 9 plus 5x equals 7x plus 9 minus 2x. Where are we going from here? Well, your brain from 2.3 is telling you, oh, combine those like terms on the right side. Love it. Combine the right like terms, and I get 5x plus 9 equals 9 plus 5x. Now, if you're paying attention, you know something fishy's going on. Because you notice that both sides of that equation are exactly the same. But you keep on keeping on. Subtract 5x from both sides. Uh-oh, cancel here, but it's also going to cancel over here. 5x minus 5x is 0, no matter what sides it's on. What does that leave us with? 9 equals 9. Well, it looks like the last problem, except this time, we're okay. 9 equals 9 is a true math statement. We know that. So what does this mean? Well, it means I could have done something wrong, but for the sake of time in this video, I promise you I didn't. If you don't believe me, check my work. Go through and try and solve it a different way. You're always going to end up with some number equaling the exact same number, even if you get down to 0 equals 0. So what does this mean? Well, this is the opposite of no solution. This is known as the identity or infinite solutions. Right? Identity or infinite solution. So we've talked about, okay, sometimes there are special equations that there's no number I plug in for x that will make it true. Typically, one number I plug in for x and it makes it true. But here is another special case where no matter what number I plug in for x, it's going to be true. You could plug 1, 2, 3, 4, negative 37, 138,002. in for x, and that equation is always going to equal the same thing on both sides. Again, if you don't believe me, try it. So what are you walking away with this video? What's the 10-second summary? Solving equations like never before. Just like we've been doing, we're solving. We learned how to solve word problems when there are variables on both sides, and then there are some special cases. Watch out if you have a variable on both sides. Maybe it turns out if you do your math right, you might get a no solution. One number equals another number, but you know it's not true. 0 never equals 9. Or you run into 9 equals 9, which is always true, which means it's infinite solution. I need you to know infinite solution and identity, and I need you to know how to recognize no solution. If you run into this on the test, it's not sufficient to just say 9 equals 9, I'm done, or 0 equals 9. I need you to write out identity or infinite solution if it's a number equally in the same number, or if it's a false math statement, 5 equals 4, then I need you to say no solution. That's 2.4.